ANSYS, go ahead and select steady state thermal analysis. You can either double click or drag it. So once you do it, I'll leave the name down here because we haven't looked at the model yet. Maybe with the model name you would have guessed it. So yeah, I actually put it or just leave it as it is. Engineering data, we aren't doing much with engineering data today. We'll just take the model, give some temperatures, and try to understand what it actually does. So for now, go to geometry. You can go ahead and import geometry, either browse or if you have already opened it, you can just select it. Okay, once you select it, go ahead and double click geometry. Let's go look at the model. Okay, so I'm gonna hit generate just for it to get loaded. Okay, so down here is what we have down here is the cylinder head, the cylinder block. And when you look at the cylinder block, you could see the fins surrounding it. So can you let me know, why do people generally use this type of structure? Why can't they just use a solid design, just say that something like a square profile? Why do they generally have something like this fins on a cylinder head? So one thing, background of a cylinder block or cylinder head is it's gonna take high temperatures. So so could you let me know why generally we have a, when you look at an engine block, just take your bike, and if it's a geared bike, you can actually look at the engine block, and you would see fin structure, something like this. So what do you think is the use of fins? Yes. It increases the surface area and allows for a greater heat dissipation. You're totally right, Nikhil. So it might look easy, like when you look at the fin, it's gonna be trickier when you like start designing it, but we aren't doing too much of it. But whenever you get a chance, I'm sorry, I'll actually. Thanks for letting me know, Nikhil. I hope you can see my design model now. Okay, so looking at the design of a fin, it's gonna be it's much tricky. So whenever you get a chance, maybe even using ANSYS, you can just try to do some fin design. So when you like take this cylinder block, just try to do some sketching, something like the fin, give a circular path to it so that it can take the profile you want, and that's how you can get a hands-on experience designing a fin. So that's your answer is totally right, Nikhil. It's actually used to increase the surface area and help for greater heat dissipation. So cylinder block, as I mentioned earlier, it's gonna take the temperature is gonna see is really hot. So when you look at the ambient temperature, let's say it's gonna be 20 C, 30 C, 40 C, and that's gonna be ambient. But when you have all this combustions going on inside your head, it's gonna see very crazy heat dissipation going on inside. So one thing you could do, so for today's class, I'm just going with structural steel material. So one thing I would recommend you guys to do is try aluminum material, just to see how different how different it is. So what is the temperature difference you see when you have a structural steel? You can actually play around with the different uh, materials we have in ANSYS library. Just try to play around with it. Uh, we generally see all these material properties, right? So for every materials, there are like a list of properties. So one important thing when you come out with thermal analysis is the thermal conductivity, right? So just go just browse for the different thermal coefficients you have for each material. Before you do that, try to do a simulation of it. So with what we do today with static structure, play around with different materials. Just see, just understand by looking at your results what it is like, how different is it is uh, when you use different materials, and then go back online, look for the material properties, try to understand it now. So that's how I think that's the best way I would say for you to make sure you remember this always. It's not that you go look at the properties and just assume things. Here we are trying to do something what the properties say. So that's one approach I highly recommend you guys to do as we do our analysis. Because due to time constraint, we won't be able to uh, take a lot of materials, but you have a template what you could follow. Like for today's analysis, since we are doing it, the default material, take time, go ahead and use different material properties and see how it works. That's how I think that's a real good approach I want you guys to take. So with that said, as said you here, you can see this. This is the engine block you have, and uh, this structure is actually a bit complex. They have all other steps going on. They have this fence, but as said you, today we are we, uh, looking at how these fins would help uh, the heat dissipation going on. So another thing which you guys can do is like just try to uh, design a cylinder head without fins. So it will just have like a square profile. Just play and give some values to it, and just just see the difference you see in the temperatures. So we do know that fins uh, in automotive is actually used to like help out with heat dissipation. But let's take an hands-on experience, go ahead and do it, and understand ourselves with that. Okay, so uh, just wanted to give that background here, and here you see just it's only one uh, one one part of the one body. So I'll just go ahead and close this, and I'll actually minimize it. So I'll go ahead and open model, which is step 4, which will open the mechanical interface. And I hope now you would be able to see my screen. Okay, so you can now actually use this pan zoom rotate option, or use your mouse to do your rotating steps. Just try to align it in some position so that you have a view of the interfaces. Okay, so as said, I'm not gonna talk more on other steps. So it's gonna be just uh, do some thermal analysis to it. So for now, uh, I'm actually trying to size the mesh. I'm actually giving some values to it. Element size as 10 millimeter. So you can actually give it or just leave it, wait for ANSYS to do its default stuff. But due to the restriction we have with the software, we might or may not uh, uh, get it meshed. So just let's leave it till the end. If it doesn't solve, you can go back, uh, just play around with value. This is the value which I played around and made sure that it's gonna work. So you can start with a smaller value like 2 1 something like that, point 0.5 millimeters, something like that, and just try to increase it until it gets better. Okay, so this is one value which I came up with. You can even still go lower, uh, but not take too much time for solving. I'm just putting a coarse mesh which is at 10 millimeter size. Okay, so I'm not doing much on it. So for now, we'll do what we did last week. So last week was a simple problem. We just had a plate, and it was actually it had some temperature to it. It was surrounded by ambient air, and we were actually seeing what it takes to bring the temperature of the bar to an ambient temperature. So for today, we try to simulate what we actually see in engines, or let's say whenever there's some combustion going on inside the cylinder head. Okay, so we know the cylinder head is gonna run hot. Okay, so with that said, we'll by default give some ambient temperature. So it's gonna be some, let's say we'll go with the default value. So that's going to be ambient. And to simulate what a cylinder head takes, we give some values to it. So we'll increase, we will put some temperature, and if needed, you guys can play around with the temperature and see what it takes, and how better is the fin design, which helps in heat dissipation. Okay, so with all this said, I hope you would now know what type of problem we are dealing with. So it's is it gonna be convection, convection, or radiation? That's my question for you guys. Okay, so here you are. I'll take the second part, Nikhil. Your answer was second part was convection between block and environment, and convection within block. So we don't have an other assembly which is within the cylinder block. Okay, so might be you're right in terms of when you have some interaction between the block. Let's say you have some, we're trying to do some piston simulation within the cylinder head. Yes, that time you can call it as conduction, but right now we are like letting ANSYS know that this is the temperature what the cylinder head, yeah, like the inner face is gonna see due to combustion, and you have this outer ambient temperature which is surrounding it, and let's see what it. So at the end of the day, for today's class, we are looking how a fin can actually why fins are used for a cylinder block designs, right? So we're trying to understand, as you mentioned, for a head, gray fins increases the surface area and allows for greater heat dissipation. We are trying to uh, get a better picture of what the functionality of a fence is. So for today, as a whole, we looking at the problem statement. This is a convection between the block and environment. So I take the second part of yours, and you're totally right, Nikhil. So looking at our the statement of what we're planning to do, it's going to be the second part of your answer, which is going to be right. Okay. So with that said, uh, uh, I'll go to steady state thermal. So in that you can go to insert temperature. So this is one way of giving temperature, convection, all this stuff. Or when you hit the steady state thermal, you would automatically get these options in the screen, which is on the top. So this is another way which can actually save time, because it's not that you need to always hit this, go to insert. So when you go hit temperature here, it will actually bring the temperature here. Okay, so just to uh, make it so simple and less time consuming, you can make use of these options. So this applies even when you like apply stress, strain, all these stuffs when you do static structural analysis. Okay, so that said, believe as I mentioned, we need to let ANSYS know that this cylinder block, when like the interfaces are seeing a high temperatures. Okay, so with that said, um, I'll have to select the interfaces. So I'll select interface. You can just play around with the span, zoom, rotate, and make sure select the interfaces. So that should be green. So we're letting ANSYS know that this phase of the cylinder block is seeing high temperatures. Okay, so once you select the phases, please go to geometry and hit apply. And temperature again, this actually takes a default of 22 degrees C, but that's not what we need. So let's say the cylinder block is seeing a temperature of 300 degrees C. So it's running hot, pretty hot. So I'm just giving, you can just play around with this value for uh, now. I'm just taking 300 degrees C. See, just letting ANSYS know that yes, this is seeing a very high temperature. Okay, cool. So with that done, I'll then go to steady state thermal. Again, I'll go to I click it, insert, select convection, or select it down here. So we need to let ANSYS know that we're trying to do some convection problem. So I'll go ahead and select that, and now it's asking me what geometry to select. So in this case, it's gonna be all other faces which is like open to the ambient environment, and which is, and it's going to be the only interfaces which we need to deselect. So you can select this solid body and select and deselect the interfaces, or you can just right click, select all. So once you select it, you can see the whole model is changed to green. Keep your controls pressed. Go ahead and select the interfaces. Make sure control is pressed. Okay, so now you see all phases are selected except the inner two faces of the cylinder block. Okay, so once you do that, go to geometry and hit apply. So right now it says that this is gonna have an ambient temperature, like it's surrounded by ambient temperature 22 degrees C, and right now we'll have to provide the film coefficient. So to provide film coefficient again, as showed in the presentation initially, it has some values, right? So it ranges from 5 to 10 power 5 e power minus 6, something like that, right? So in film coefficient, for now by default, we'll go select import temperature dependent, or the second import option, and select stagnant air, which is simplified case. So this is a type of library which ANSYS has. So we'll just select that, and you should actually see around 242 phases being selected, coefficient value already given, uh, film coefficient given, ambient temperature of 22 degrees C. Okay, I hope you're still following with me, Nikhil. So you can just stop me if you want me to repeat anything. So all I have done is let ANSYS know that the inner phases is going to see high temperature, and the outer phases, the other phases are seeing it's surrounded by ambient temperature, and we just gave the film coefficient values to it. Okay, with that said, we go to solution. Go ahead and select insert again. So this is one way of doing solution insert thermal temperature, or you can go ahead and select it down here. So whenever you hit all these steps, these option gets popped up here. So this would actually save time. So I'll go ahead and select thermal temperature. We'll actually look at what it actually does. So we are letting ANSYS know that interface is gonna see this temperature and surrounded by air, and what it actually takes. What does how the effectiveness of the fins for this design. So once you do that, go ahead to solution and hit solve. So we'll wait for ANSYS to solve it again. If you had went for a default mesh, if you're lucky, it would get solved. If not, you'll have to go back to mesh, change the sizing. You can just play around with it. Okay, so with that said, yes, so I think the solution has been done. When you look at the mesh again, it's going to be a coarse mesh. Again, one restriction we have with ANSYS is that the number of elements we use. So if you want to know what's the number of nodes or elements we have, go to mesh, and in statistics, you can see the total number of nodes used or the elements used. So I believe the student software has a restriction of 32 degrees. I mean 32K, 32,000. So when you look at, I actually gave a mesh size of 10, so it actually worked. Maybe you can go a bit lower. See how low you can go. But again, if you are so interested in giving a better mesh, you can use all the nodes which I've shared for meshing. You can try to refine which your area of interest, like which is the area of interest. Go there, refine the mesh down there, give some phase meshing. That's the other option we have. Okay, so right now we have temperature down here. I'm just looking at the solutions. So as you could see, 300C was the temperature we actually gave, and the temperature and the outer surface of the ambient temperature was somewhere around 20C. So when you look at this plot, you could see the interface is still seeing high temperature 300C. But one good thing you could see here is like the heat is getting dissipated. Okay, so it tries to moves on away, and when you look at these fins, that would give you a better information. So this fin structure has actually helped in like distributing the temperatures, and that's the effectiveness of fins. So you could see somewhere around 300 is what we see down here till 245, right? So that's how heat gets dissipated. So as I mentioned again, you can just play around with this value, like try to get the sizing of this whole cylinder block, try to do a solid square structure or something like that, and see how the temperature profile looks. So by that way you can like uh, help yourself understand the effectiveness of all these steps. Okay, so one thing, when you look at this cylinder block in terms of a design problem, you can see the design actually looks pretty good. The reason because you don't see any sharp corners which is down here, so you can see they are pretty well used, made use of the fillet structure. And again, when you look at this holes down here, it's not straight near to, it's not too much cornered to another slot. So when you look at this design aspect of this one, to me it looks pretty good. uh, there are gonna be areas of stress concentrations which it can which obviously it can have, but as a whole, when you look at the design, it looks pretty good to me. Okay, so this is what we are seeing down in terms of temperatures. So we'll go to solution again, try to see the total heat flux it has. Okay, so uh, when you look at it, it's all minimal, and I just used the probe to see the maximum. So again, heat flux is heat transfer through a unit area. So looking as a whole, like when you look at this phase, it has a more surface area than any other region. So all these regions are like, since looking at in a dimensional way, dimensions of this are so small, but since this phase has a large surface area, it's gonna have some, it's gonna have a better heat transfer rate which is going on. So that is what this would say. So what we can do is like we'll just play around with the temperatures down here. So just go ahead and give 500C and see how it looks like. Okay, so as you can see, as we go high in temperature, yes, the fin structure is like able to help dissipate much heat. So you can see a drop from 500C from the center to away region is like 400C. So that's pretty good design of a fin, which helps to have a better heat dissipation going on. Okay, so so this is what I thought of covering for today's class. Like we actually took a simple plate for last week. So today I thought, okay, let's take a good application which is like an automotive application. See what it is, uh, how fins can be used to do some thermal analysis. Okay, so that's one thing which I wanted to cover today, just to give you a better picture